On this example, we want to find the derivative of 2x minus 7 over 4x plus 3, all raised to the third. Here we go. Fasten your seatbelts for this one. So I have these two functions on the inside, all raised to the third. So if I were to just ask the question, take the derivative of this, 2x minus 7 raised to the third, what you would do is you'd use chain rule. 4x plus 3 raised to the third, chain rule, same thing. Both of these are being in raised to the third now, so they're dividing by one another, all raised to the third, so we have to use chain rule on this whole expression. So I'm going to use chain rule, so this has become 3 times the original inside, not doing anything to the inside here, 2x minus 7 over 4x plus 3, raised to the second using chain rule. But then what happens with chain rule? So if we were to just take the derivative of this, it'd be 3 times 2x minus 7 minus 1 to the second times the derivative of the inside. So now I have to take the derivative of the inside. How do I take the derivative of the inside? I use quotient rule because I have 2x minus 7 over 4x plus 3. Got to use quotient rule now. So yeah, we're using chain rule, quotient rule. This is getting fancy. Let's go ahead and do that. So now I'm going to take the derivative. I'm going to put this in a bracket. I'm going to take I'm going to use the quotient rule. Quotient rule is the derivative of the top. So derivative of 2x minus 7 is just 2 times the original bottom, 4x plus 3, minus derivative of the bottom, which is 4, times the original top, 2x minus 7, all over the bottom squared. That's quotient rule. Bottom squared. So again, what I just did is I used chain rule. 3 times 1 is 3. Original inside, 2x minus 7 over 4x plus 3. 3 minus 1 is 2 times the derivative of the inside. So I get this whole statement here. So now I need to do some algebra. I'm going to distribute the 4. I'm going to knock out 2 steps in one here. Notice how this is minus. So we want to actually do negative 4 times 2 and negative 4 times negative 7. That's a very common mistake that I see of people not distributing that negative. What some people might do, don't do this. I'm just going to show you a potential mistake here. They would distribute the 4, so you get 8x. You distribute the 4, so then you'd get minus 28. And then since this is minus, they would just write it like that. But that's not how we want. We want minus 8x minus 28. So we want to distribute the negative into there. So make sure you're doing that. So if you want to do this as just negative 4 times 2, negative 4 times negative 7, that's 100% fine. But that's just a really big mistake that can be made that you don't want to make. So I'm going to do negative 4 times 2, negative 4 times negative 7, and also distribute the 2 into here. So let me bring this over here. So 2x minus 7 over 4x plus 3 raised to the second. And then I did 2 times 4, which is 8x. 2 times 3, which is 6. Distributing the negative 4. Negative 4 times 2 is negative 8x. Negative 4 times negative 7 is a positive 28 over 4x plus 3 squared. Nice. I am liking what I'm seeing because of this. Look at this. 8x minus 8x. Gone. 8 minus 8 is 0. Then I have 6 plus 28, which is going to be 34. So let's rewrite everything. A little tiring. 2x minus 7, 4x plus 3 raised to the second. And then I just have 6 plus 28, which is going to be 34, over 4x plus 3 raised to the second. So right now, we are not done. Some fancy stuff is going to happen. So pay attention. I'm going to do 3 times 34. I'm also going to change this to 2x minus 7 squared over 4x plus 3 squared. Now the reason that I'm doing that, the reason that I'm going to do that is because of this. On the bottom, I have 4x plus 3 squared. On the bottom, I have 4x plus 3. So what I could do is I could rewrite this as 4x plus 3 squared times 4x plus 3 squared which is going to give me 4x plus 3 to the fourth. 2 plus 2 is 4. Multiplying by the same base, we add the exponents, so you get 2 plus 2. So I need to break this down, though, a little bit further. So I'm going to do 3 times 34, and then I'm going to rewrite that. So 3 times 34 is going to be 102. And then I'm going to rewrite this as 2x minus 7 squared. Over 4x plus 3 squared times, and then since I wrote that 102 out in the front there, I'm going to have 1 over 4x plus 3 squared like that. And I didn't necessarily need to write this step down, just kind of showing you the process that you would take, but you could probably just do that more mental. Well, this is going to be 2x minus 7 squared, 4x plus 3 squared, it's 4x plus 3, 4x plus 3. So then we'll have 102 2x minus 7 squared over 4x plus 3 to the fourth. Yeah, that was a little tricky. Not something that is obvious. Like, that's definitely something you got to think about and try to look a couple steps ahead. It's almost like playing chess. You want to be a couple moves ahead, so you have to sort of project this like, all right, I have 4x plus 3, 4x plus 3. This is raised a second. All right, I could do something with that, and then go through. Because if there wasn't, like if this was like something different, which with this type of problem, like you're most likely going to get some sort of term that can go together here. But what if it wasn't the same? Then you really couldn't do much. So then you just multiply the 3 and 34 and probably just leave it from there. But in some cases with this type of problem, you will see some common factors here where you can simplify that a little bit more. So that would be our answer. Very good problem there.